Okay, so first question, I think this came this year, right? The coefficient of determination R square is an increasing function of the number of regressor. B, it is a decreasing function of the number of regressor. C, it is unaffected by the number of regressor. D, it is always positive. So which one is correct? ନାଇଁ ଏଠାରେ କ୍ଲାରିଟି ଆସୁନି ଆମେ ଏଥିରେ ହିଁ କରିବା ମଧୁସ୍ମିତା this is directly first of all ଯୋଉମାନେ ଆମର r square what is r square ମଧୁସ୍ମିତା
Sir, goodness of it
r square is
means coefficient of determination, but sir, we measure through the R square, we test the goodness of fit of the regression model.
okay, very good. Okay, now this question is direct, right?
Yes, sir.
So basically I think those who doesn't means you have not studied, maybe few of them have not studied, so just for them, so first of all goodness of fit, we calculate goodness of fit of the fitted regression line, okay, just to find out how well the sample regression line fits the data, okay. So coefficient of determination R square in two variables case आमे एमिति लिखंती जस्ट लिखि दउची फॉर योर क्लैरिफिकेशन R square R square आमे लिखिबा एमिति लिखिबा R square for two variable case, okay, okay madhusmita,
Yes,
and
sir.
capital R square लिखिबा multiple regression case है multiple regression case. So basically as already you told आमर सदाबले टार्गेट कौन जे रेसिजुअल अराउंड द रिग्रेशन लाइन शुड बी आज स्मॉल आज पॉसिबल, राइट? ताहले कोएफिशिएंट ऑफ डिटर्मिनेशन इज ए समरी मेजर that tells us how well the sample regression line fits the data. Are you writing?
Yes, sir. Sir, please say, can you please say it again?
R square, the coefficient of determination. Let me write it, okay? One second. One second. It is not here. Yeah. Are you writing?
Yes, sir. Yes, sir.
The coefficient of determination R square, which is in two variable case in bracket, or capital R square in case of multiple regression, is a summary measure that tells how well the sample regression line fits the data. ହେଲା
Again, sir.
Clear? तो माननीय आमर देखा आमको ब्लैक बोर्ड यूज कले होंदा let me tell you जदि एटा रहला y एटा गोटे वेरिएबल एटा तमर x हैला तो ये आर स्क्वायर कौन हो बोलो देखिए आर स्क्वायर विल बी हाउ मच इन दिस केस मधुस्मिता
Sir, x into y square.
हाँ ना मु कहूँ जे फास्ट ऑफ ऑल एटा तमर डिपेंडेंट वेरिएबल आ एटा हो जे इंडिपेंडेंट वेरिएबल
One variable.
आर
Yes.
स्क्वायर कौन मेजर करे आर स्क्वायर मेजर करे जे होची ईएसएस अपन टीएसएस राइट ईएसएस तमर होची एक्सप्लेन सम ऑफ स्क्वायर अगेन तुम कहूची ईएसएस कौन मेजर करे एक्सप्लेन सम ऑफ स्क्वायर हमें डिटेल ले पढ़ीबा और टीएसएस कौन मेजर करे टोटल सम ऑफ
Total sum of
स्क्वायर टीएसएस रो हमर बेसिकली टीएसएस आम क्या कहते टोटल वेरिएशन ऑफ द एक्चुअल वाई वैल्यूज अबाउट देयर सैंपल मीन ओके तार फॉर्मूला कौन टीएसएस रो फॉर्मूला होची समेशन स्मॉल वाई स्क्वायर दैट इज इक्वल टू समेशन वाई आई माइनस वाई बार स्क्वायर होल स्क्वायर दिस इज बेसिकली total variation of the actual y values about their sample mean, right? तो ये सिस्टा कौन sum of square due to regression or due to the explanatory variable or which is explained by the regression. It is called explained sum of square. बुझिपारछ ESS ର फॉर्मूला कौन ESS ର फॉर्मूला होची बाइवेरिएट रिग्रेशन क्षेत्र रे हमें बेसिकली नॉर्मली आम बाहर करती समेशन वाई आई हैट स्क्वायर और दिस इज इक्वल टू सम ऑफ वाई आई हैट माइनस वाई हैट बार स्क्वायर विच इज इक्वल टू बीटा टू हैट स्क्वायर into summation xi square. Let me write it again in a plain sheet of paper. First of all, is it clear, Madhusida?
yes, sir. Yes.
No, we have not discussed the regression yet. Actually, that is the whole problem. Means already we had discussed in the previous like in the December, but right now we have not discussed. Okay, so we will come to that once we will do the bivariate regression, then this topic will come. Okay, but right now I think it is time to just focus on the derivation or the formula so that we can save time. So just I will tell you what is r square and what is the purpose. Okay, so r square is either you can calculate r square as ESS upon TSS, please write it down, or it is 1 minus RSS upon TSS. Okay. So R square measures the proportion or percentage of total variation in Y, which is explained by the regression model. Okay.
Sir, R square measures the proportion.
R square measures the proportion or percentage of the total variation in Y. R square measures the proportion or percentage of the total variation in Y, which is explained by the regression model. So simply, if this R square will be increasing, then it is good. It means the model is a good fit, right? But there are some complications regarding R square interpretation that we will discuss later on. But right now, at this point, you should know how our ESS will increase. Chinmay? If you add more and more independent variable to the regression, then your ESS will increase. Is it clear? Chinmay, are you there? I think she is not there. So, R square measures the proportion or percentage of total variation in Y explained by the regression model, right? So, usually when you add more and more independent variable to the regression, then your ESS will increase. Okay? And subsequently it will be 1 minus, because your TSS is equal to ESS plus RSS. So if you divide TSS across, then it will be 1 minus RSS upon TSS. Now what is the question? Madhuchita, what is the question? The question what it is given. Am I audible, Madhuchita?
Yes, sir. The coefficient of determination R square. Question is
First of all, it is saying it is an increasing function of the
ring function.
number of regressor. This statement is correct or not? Yes or no?
Yes, sir.
Why S? Tell me. This is true.
As you said, if we increase the independent variable,
Okay.
then R square is also.
Yeah, you will say, not as I say. You will say that as R square is equal to ESS upon TSS.
Yes, sir.
So ESS depends upon the number of regressor. So as ESS will increase when we increase the number of independent variable in a regression model. So, or hence, R square is an increasing function, because if your numerator is increasing, TSS remaining the same, then your R square will be increasing. It will be an increasing function of the number of regression. Correct? Is it clear?
So this is indirectly related, I think.
Not indirectly, directly related, na? Because ESS is directly, it is you are calculating, na? Simply when your independent variable will increase, then your ESS will increase. Direct relation, not indirectly. Okay?
Mm-hmm. Yes, sir.
Because your ESS directly depend upon the number of regressor in the regression model.
Mm.
I'll show you, taking the data in a Gretl or Stata, we will do it. Okay.
Okay, sir.
But right now, just you should know that it depends upon ESS and the formula and how the ESS is calculated. Well, as I already told you, ESS is see, always you should write down. Okay, ESS means what is ESS? ESS is your summation yi hat minus y bar whole square. This is your ESS. And what is your RSS? ESS means explained sum of square. Again, I am just telling for your clarity. Explained sum of square. Then RSS is your summation UI hat square. That is your residual sum of square. Are you writing it down?
Yes, sir.
Just I think some of you might have forgotten. Then similarly, TSS is summation yi minus y bar whole square. That is your TSS. Total sum of square. Okay?
Yes, sir.
So, based on the question, definitely your ESS will depend upon the total number of regressor in your model or total number of independent variable in your regression model, right? So first statement is correct. It is an increasing function of the number of regressors. Clear?
Yes, sir.
Now we'll go to the second statement. So this is true. Then it is a decreasing function of the number of regressor. Because A is true, then definitely this is not true. Correct? Then D is C is it is unaffected by the number of regressor. Chinmay. Chinmay, are you there? Hello? Okay, she is not there. Madhusita?
Yes, sir.
C is unaffected. It is saying that it is unaffected by the number of regressor. Is it
False, sir. False.
false? Okay, very good.
Sir, I have a question.
Madam?
Sir, I have a doubt here.
Okay.
Suppose I am taking a regressor which is not affecting my y.
Okay. Very
Okay.
good.
So in that case, if I increase my regressor, that may not change or increase my explained sum of square. So that is not affecting my y, na? So
No,
that's why in the answer it is also mentioned adding regressor never decrease SR square. Means it may increase or may constant possibility.
yes.
So in that condition,
Mean,
A has a high chance that it will increase. There is also a possible chance that C may happen. If the regressor is independent, two variables are independent. Y and my x1 suppose the regressor is independent. So in that condition, this is not affecting the regressor.
no. I'm just, madam, I am telling you.
Yes.
You just simply I am telling you what is the ESS formula. ESS formula is, I am telling you. ESS formula is like this.
Yes,
It is we write in deviation form.
Yes, sir.
We write ESS is in deviation form. It is like summation
YI.
small yi
Small
hat
YI.
square, which
Yes,
is
sir.
equal to beta 2 hat square into summation xi square.
Yes, sir.
Okay, and
Okay, sir.
this is the actually formula of the Yes, or explain sum of the square. Okay.
Yes, sir.
Now the question is, when we are saying R square is your ESS upon TSS, right?
Yes,
And
sir.
ESS is nothing but summation small
Small
y hat square, and
by
TSS is
this.
nothing but in deviation form. I am writing in
Yes,
deviation.
sir.
And then this is beta to hat square summation xi square upon summation yi square. Now the question is, because it is beta 2 squares times summation xi square, so if there is a bivariate regression, it is fine, because I am just using for a bivariate regression here. Okay, but in case of multiple, you can say uh, multiple regression, so this will go on increasing. Definitely it will have a positive impact if you will assume the TSS to be constant. Okay, and
Sir.
as you are saying, sometimes there might be possibility that it is not, your R square is not increasing. That is why we will discuss another concept, adjusted R square.
Yes, sir.
But by default, we will take a data. You will
Yes, sir.
see what you are saying. We will see that whether it is increasing our independent variable or not. Can we do that?
Yes. Yes, sir.
Okay, let us take one data.
Okay.
Okay, let me see whether I'll go to Gretl. I think, madam, you are having also the Gretl, right?
Right now, I don't have the Gretl.
No, in your laptop it is installed. I have installed, I know.
Gretl.
Gretl software.
So it was installed perhaps in the, yes, department computer.
Okay. I can install it in your laptop also. You can use.
Okay, sir.
So, first of all, let us try to understand. In case of multiple regression, I am just thinking which data I will take. One data I am just checking. So let's see, table 7.3. We'll go to open data, sample file 7.3. Output capital lever in Taiwan. Okay, madam?
Yes, sir.
So basically, this is a estimation of Cobb-Douglas production function.
Yes, sir.
Okay, ma'am? Or
Yes, sir.
this one we will take later on. Let me just check if there is any other better easy example. As it is, if I can use.
Yes.
Chapter 6. One second. Child mortality, one example was there. I don't know where is the table data. Child mortality example. Okay, this one also we can use, not a problem. Let us see, ma'am. So what we can do is, you can do like add log y, ln y, then ln x2. Then because we are using, we are estimating, madam, Cobb-Douglas production function here.
Yes, sir. Yes, sir.
That is why we are converting into log,
Log. Yes, sir.
right? Because we are converting
It will be linear function.
non-linear function to linear function, if you have remember.
Yes, sir. Yes,
So we
sir.
are doing that.
Yes, sir.
Now what I will be doing is I will estimate this regression model. Okay. Now you just see. Suppose this is
Log
our
y.
dependent variable.
Yes, sir.
This is our independent variable.
Independent variable.
So we will estimate this is one model. Okay.
Mm.
So this is our what you can say, one regression.
Nine.
So what is our R square? We got 0.67592.5. Okay. So this is our R square, madam.
Yes, sir.
Now if I'll do, I'll go to another model. Then I'll add this, and this is our dependent, you can say. I will just see. So constant is minus 3384, right? But
Yes, sir.
labor, because I think labor day was actually x2. X2 is the coefficient for the labor. Okay.
Yes, yes, sir.
And capital,
X3 for capital.
x3 is capital. So now I just see the first of all, this is a log model, so it is also another learning which we should know. First, you know what is the interpretation of this coefficient, madam? 1.49877.
If this labor is increased by 1%, then the output will increase by 1.49877%.
Let me tell you. First of all, these are basically this is output elasticity of labor and capital. Okay.
Yes, sir. Yes, sir.
It means you will say like this: over the period of the study,
Yes.
holding the capital input constant,
Yes, sir. Yes, sir.
a 1% increase in the labor input
Yes.
led on the average to about a 1.5% increase in the output.
Yes, sir.
Okay.
Yes, sir.
Means holding,
Capital.
you will write like this. In other words, over the period of the study, holding the capital input constant, a 1% increase in the labor input will lead to, on an average, 1.5% increase in the output.
Yes, sir.
So similarly, we can interpret the capital also.
Yes, sir.
Okay.
Yes, sir.
So you will interpret like this. Similarly, holding the labor input constant, a 1% increase in the capital input will lead to, on an average, 0.5% increase in the output.
Yes, sir.
Now, if we will add both of these, x2 and x3,
Yes,
then
sir.
you will get the return to scale parameter.
Yes, sir.
Then definitely it is showing that 1.49 plus 1.50, let's assume it is greater than 2. So obviously it is showing that the particular sector
Increasing return
is
to scale.
having increasing returns to scale.
Yes, sir.
Okay, madam?
Yes,
Now,
sir. Yes, sir.
R square we got, you can see over here. This R square we got 0.8890.
Mm.
So Madhusmita, how you will interpret this ray r square? This is my first question. Sangeeta, are you there?
Yes, sir.
So how you will interpret the r square here?
Give
Okay,
me a moment, sir.
you want to skip?
Sir, 1 minute, sir. Let me frame the answer.
Sir, may I try?
Okay, you can try.
Sir, R square value 0.88 means
8890.
90. It stated that our independent variable
Uh,
explain the about the dependent variable. Uh,
okay, not a problem.
Sir, can I try?
Yes.
Sir, R square states that the independent variable is explaining 88% change in the dependent variable.
It is very simple interpretation. So let me tell you how you will interpret. The R square value here it is 0.8890. Simply I told you that first of all whatever the R square value you will get, you will multiply by 100 to interpret. So if you will multiply, because it is close to 89, so if you will multiply by 100 it will be 89%, right?
Yes, sir.
So it means there is about 89% of the variation in the log of output, okay, which is explained by the log of labor and capital. So what is the interpretation? 89% of the variation in the log of output is explained by the log of labor and capital. That is how you are going to interpret. Okay, but now the question was not that, because just I deviated a little bit. More important here it is, as Bhakti ma'am asked this question, madam, when we have taken only one independent variable, our R square is 0.675925. Now,
Yes, sir.
what you can do, you can go or you can do a ANOVA here. So this is the ANOVA for this model. Okay.
Yes.
So this is the regression. This is ESS and this is RSS, and the below one is TSS.
Yes.
And so I think tomorrow I can install this Gretl in your in your system also,
Thank
so
you.
that you can practice parallelly. Now you just see, this is ESS, RSS and TSS.
Yes.
So ESS has increased, isn't
Yes,
it?
sir.
Now, yes, of course, there are situations where R square will not increase if the independent variable is not having any relation with the dependent variable. In that case, the R square, or if the variable is not statistically significant, then there might be possibility that R square will not increase, but ideally R square will increase. In the most of the time it will increase. I will discuss, madam, this in detail,
Yes.
means the multiple coefficient of correlation, why and what are the complication of R square. I will discuss in detail, madam.
Okay, sir. Okay, sir.
Now I think because it will be little technical discussion for others, so they have not come to that far. So let us focus on the. But
Yes.
what I was trying to
Okay.
prove here is R square has increased, right?
Yes, sir. Yes, sir.
But there are also situations. Sometimes the R square will decrease also, not a problem. So
R
because
square will decrease.
R square will decrease also. I will
Oh,
show
this
you.
also happens. Okay, sir.
I will show you. There are
Oh.
examples. If the regression is not actually adding one explanatory variable, if it is not statistically significant, in that case R square will uh, reduce also. Okay.
Mm.
So there are questions like I will tell you in the Gujarati book. So there are questions which we will discuss later on, not today. Now, what is actually important over here is first one thing we know without going to the complexity, if you will increase the independent variable and if that independent variable is statistically significant, okay, which we can easily observe it from the t ratio and the associated p value of the t ratio,
Yes.
then obviously the r square will increase in this case. Okay, madam?
Okay, sir. Okay, sir. Thank you, sir.
So now so unaffected by the number of regressors, that statement will be false in this context. D is always positive. So the answer will be A and D only.
Mm.
Adding regressor never decreases R square, and R square, the maximum value of R square will be 1. So always
Yes.
it will be non-negative, and B and C statement are false.
Yes.
Okay. So now we'll go to the next question. Next question is, given the sample size 20 and 15 with respective sample variance 35.53 and 34.92, the calculated value of F statistics is. This is a direct question. S1 square, you divide it. Okay?
Yeah.
Madhusmita?
Yes, sir.
So how you will decide which one you will put in the numerator? Always put the larger variance in the numerator.
Sir, S1 square means what? Sample variance.
S1 square is sample variance.
Yes, sir. Yes, sir.
Uh, because I think F distribution we have not discussed, right? Because I thought I will discuss, but I have not discussed. So that might be the reason. You might not be knowing F distribution, or you have to review the F distribution.
Sir, basically, you said that the F distribution, not F for the overall significance level, to measure the overall significance level, we use the F star.
No, that is for a
F test we had studied, not F distribution.
no,
Yes,
but F distribution and F test there is a relation. It's not that F test is not coming from F distribution. Okay. So first of all,
Yes, sir.
F is what? Who can tell what is F distribution? And F statistics is coming from the F distribution only. Okay. So if Z1 and Z2 are independently distributed chi-square variable with K1 and K2 degrees of freedom. So we can write like this. F distribution is Z1 divided by K1, then it will be Z2 divided by K2. So basically F distribution is basically known with the statistician Fisher. Okay. So it is with K1 and K2 degrees of freedom, right? So Bhakti ma'am,
Yes, sir.
you will write F distribution like this. So here our
Okay, sir.
Z1 and Z2 are independently distributed chi-square variable. Means
Okay, sir.
Z1 and Z2 are basically independently distributed chi-square variable. Okay?
Okay, sir.
And
Actually, sir, I have not properly studied this chi-square distribution also. Either chi-square or TF this
because
distribution.
I have not discussed, but let me tell you, chi-square distribution is basically you write like this. Means your Z is basically standard normal variate. So it is Zi square. So this is chi-square
Yes,
distribution.
sir.
1
Oh,
to K. Basically here Z1 and Z2 up to Zk, they are standardized normal variables. Means they are
okay, sir.
normal variable with zero mean and
And
one
one variance.
unit variance.
Yes, sir.
So these are actually standardized normal variables.
Okay, sir.
So basically this Z, the summation Zi square, it is follows basically, or it's said to possess the chi-square distribution with K degrees of freedom.
Okay.
So we write like this, chi-square distribution with K degrees of freedom. But geometrically, if you will see the F distribution, in F we have used this Z1 and Z2. Z1 and Z2, there it is saying independently distributed chi-square variable. So chi-square variable means basically it is following your standard normal variables.
Okay, sir.
So we write like this, F K1 and K2.
Okay.
So the subscript basically the K1 indicates the degrees of freedom associated with the two standardized normal variables. K1 being the numerator degrees of freedom and K2 is the denominator degrees of freedom. ଆଉ ଗୋଟେ ବି ଜିନିଷ ଜାଣିବାର ଅଛି ଏଠି ଯେ chi-square distribution ଆମେ actually ମ୍ୟାଡ଼ାମ ସେଇ ଯୋଉ ରିଭ୍ୟୁ ଷ୍ଟାଟିଷ୍ଟିକାଲ ରିଭ୍ୟୁ 3ଟା କରିନାହାନ୍ତି ଏ ପର୍ଯ୍ୟନ୍ତ ତା ଉପରେ ଏଟା ଡିପେଣ୍ଡ କରୁଛି କାରଣ ମୁଁ ଏଟା ଏ ସେକ୍ସନଟା ରିଭ୍ୟୁ କରିନି ଏ ପର୍ଯ୍ୟନ୍ତ
Okay.
ଆଉ ଗୋଟେ ଜାଣିଥାନ୍ତୁ ଯେ ଆମର ଏଫ୍ ଡିଷ୍ଟ୍ରିବ୍ୟୁସନଟା ସଦାବେଳେ ସ୍କ୍ୟୁଡ୍ ହବ ଟୁୱାର୍ଡସ୍ ରାଇଟ୍
Okay, sir.
ଆଉ ସେକେଣ୍ଡ ଯଦି K1 ଆଉ K2 if they will become large then F distribution will approach the normal distribution.
Okay, sir.
Okay madam? Second,
Okay, sir.
another property is T square K will be always equal to F1K. Means the square of a T distributed random variable with K degrees of freedom, it is actually it has basically F distribution with 1 and K degrees of freedom. ताले हमें कौन जान ले F distribution related अच्छी chi-square सहित it
Yes,
is
sir.
also related to
T square, sir.
T distribution also नहीं कि
Yes, sir.
କାହିଁକି T square ଯଦି ଆମେ କରୁଛନ୍ତି ତାହେଲେ ଆମେ ପାଇବା F value ବୁଝିପାରୁଛନ୍ତି କି ନାହିଁ ମ୍ୟାଡ଼ାମ
ଆଚ୍ଛା ଏବେ ସାର୍ କହିଥିଲେ ମତେ ଖାଲି ସବୁ ମାନେ ମୁଖସ୍ଥ କରିବା ଭଲ ଲାଗୁଛି ମତେ ଟିକେ ବୁଝିଲା ପରେ ମୋର ଟିକେ ମନ ଗୋଟେ ଆଇଡିଆ ହବ କାରଣ ମୁଁ ଏଟା ପଢିବା ଟାଇମରେ ବିଲକୁଲ ପଢିନଥିଲି ସାର୍ ସେ ମୋର ଗ୍ରାଜୁଏସନ ଟା ପିଜି ଟାଇମକୁ
ଓକେ ତାହେଲେ ଆମେ ତ ରିଭ୍ୟୁ ତ ମୁଁ କରିବି
ହଁ ସାର୍ ସେତେବେଳେ ମୋର ଟିକେ ଆଇଡିଆ ହବ ଆଉ
ହଁ ରିଭ୍ୟୁ ନ କଲେ ଏଟା
ଏଇଥିରୁ
ହବନି
ମୁଁ ଖାଲି ଏତିକି ଟଙ୍କା ଜାଣିଛି ଏଫ ଗୋଟେ ହଉଛି ରେସିଓ ଅଫ ଟୁ ସ୍କ୍ୱାର ଡିଷ୍ଟ୍ରିବ୍ୟୁସନ
ବାସ୍ ବାସ୍ ବାସ୍
ସେଟା
ତ ଏଠି ଯୋଉଟା ଲେଖା ହେଇଛି ଯେ ଏଇ ଯୋଉ Z1 ସ୍କୋୟାର ଯୋଉଟା ଲେଖା ହେଇଛି ଏଠି ଯେ ସାମ୍ପଲ ଭେରିଆନ୍ସ ଏଠି ଲେଖା ହେଇଛି କି ନାହିଁ ମ୍ୟାଡ଼ାମ
ହଁ ସାର୍ ହଁ
ଏଟା ଲେଖା ହେଇଛି ନା
ହଁ ହଁ
ତାହେଲେ ସେ କହୁଛି ଯେ ଆମର ଏଠି ହେଉଛି ଯେହେତୁ ଆମେ ଡାଇରେକ୍ଟଲି ଏଟାକୁ ଇଏ କରିପାରିବା ଲେଖିପାରିବା ନ୍ୟୁମରେଟର କୋଉଟା ନ୍ୟୁମରେଟର ସେଇଟା ହେବ ଯେମିତି ଇଟ୍ ୱିଲ୍ ବି ଏଫ୍ ଇଜ୍ ଇକ୍ୱାଲ୍ ଟୁ s1 ସ୍କୋୟାର ଡିଭାଇଡେଡ୍ ବାଇ s2 ସ୍କୋୟାର s1 ସ୍କୋୟାର ମାନେ ମାନି ନିଅନ୍ତୁ ଏଟା ଗୋଟେ standardized normal variator square basically जोड़ा variance basically जोड़ा sample variance it is 35.53 and it is 34.92
सर ये क्वेश्चन डिग्रीज ऑफ फ्रीडम केते केते रहइबो
degrees of freedom पूरा डायरेक्ट एक्चुअली कैलकुलेट करा है मैडम एठी माने एठी डिग्रीज ऑफ फ्रीडम आमे देखिबा सेते बेले
19
जेतले टेबल वैल्यू मैडम देखिबा टेबल वैल्यू
अच्छा अच्छा
एठी तो आमे कैलकुलेटेड वैल्यू करछन ना कैलकुलेटेड एफ स्टैटिस्टिक्स वैल्यू
हां सर
तो आ गोटे इंटरेस्टिंग कथा होची मधुस्मिता और संगीता एमाने दी जण भी आरंभ करथिले मु ताम कहिथिले जो रिग्रेशन ले जोटा एफ स्टैटिस्टिक्स कहिथिले
हां
रिग्रेशन ले गोटे एफ टेस्ट आसे कि नहीं मैडम रिग्रेशन ले
हां सर हां
तो मधुस्मिता तमे कोन कहउतलो से मैटर रे कहले टिका आउथरे
Sir, basically, F test we use to measure the overall significance level in the regression model.
यस यू आर करेक्ट आ तो संगीता कोन कहउतला से जागा
ନାଇଁ ନାଇଁ ସାର୍ ତାଙ୍କେ ବି ସେଇ କଥା କହୁଥିଲେ ଯେ ମୁଁ ଆପଣ ଏଇଠି କ୍ୱେଶ୍ଚିନ୍ ରେ ମେନସନ୍ ଅଛି ଏଫ୍ ଷ୍ଟାଟିଷ୍ଟିକ୍ ତ ମୁଁ ଏଫ୍ ଟେଷ୍ଟ ବିଷୟରେ କହୁଥିଲି ତ ମ୍ୟାଡାମ କହିଲେ କି ଏଫ୍ ଷ୍ଟାଟିଷ୍ଟିକ୍ ଆମେ ପଢିନୁ ଏଫ୍ ଟେଷ୍ଟ ସେଇଟା ପଢିଛୁ ବୋଲି କହୁଥିଲେ
ନାଇଁ ନାଇଁ एफ एफ टेस्ट रो एफ स्टैटिस्टिक्स आसीची हैला
ଆଜ୍ଞା
just the formula will be different in the different context but I will show you how this 35.53 that is also how we can link to the F test okay but both of them are linked okay it is not that they are independent from each other
yes
F test and F statistics
ସାର୍ ଆଉ ଗୋଟେ ଡାଉଟ୍ ଅଛି କି ଏଫ୍
But-
ଷ୍ଟାଟିଷ୍ଟିକ୍ ମାନେ ଯୋଉ ଏନୋଭା
wait.
ଆଉ ଏଫ୍ ଷ୍ଟାଟିଷ୍ଟିକ୍
ମୁଁ
ଭିତରେ କିଛି
ଆସି ନାହିଁ
ରିଲେସନ୍ ଅଛି
ମୁଁ ଆନଭା ଆସି ନାହିଁ ସେଥିପାଇଁ ମୁଁ କହୁଥିଲି ଯେ ଏଇ କ୍ୱେଶ୍ଚନ ଗୁଡ଼ା ମୁଁ ଏବେ ନେବିନି ନେଲେ ତମର ଡାଉଟ୍
ଆଜ୍ଞା
କାହିଁକି ମୁଁ ଏବେ ଆନଭା ଉପରେ ଡିସ୍କସନ୍ କରିନି ନା ଆଉ
ଆଜ୍ଞା
ସେକେଣ୍ଡ
ସାର୍
ଭକ୍ତି ମ୍ୟାଡାମ
यस सर
ମୁଁ ଏଇ क्वेश्चन ଟା ଯୋଉମାନେ ଡିସ୍କସନ୍ ଯୋଉମାନେ ନ କରିବେ ତାଙ୍କର ଆବିଲିଟି ନାହିଁ ହଉଛି ନେକ୍ସଟ ଲେଭେଲକୁ ଯିବା ପାଇଁ
ओके सर
ତ ବର୍ତ୍ତମାନ ଆମେ
मुझे से
ପୁରା ଆସିଯିବା ଆମର ପୁଣି ବ୍ୟାକ୍ ଟୁ ପେଭିଲିୟନ ଆମେ ପ୍ରୋବାବିଲିଟିର ଅଲରେଡି କ୍ୱେଶ୍ଚନ କରିସାରିଲେଣି
यस सर
ତ ନାଓ unless until these three assignments are finished
यस सर
so next level discussion is not possible okay madhusudhan
ओके सर आई ट्राई टू कंप्लीट इट
yes sir
otherwise there will be no point it will be wastage of time
यस सर
okay
ओके
because
सर
if someone doesn't understand all this then it will be very difficult
यस सर
I'm sorry to say that but it will take little
नो
time
नो सर आई विल डू इट
because see question number 3 now I cannot discuss like this rank order condition
नो
you need time of course question number 4 we can discuss but again arima process this is also will not able to discuss only we can discuss some few exam questions with related to probability only are you getting because there are
Yes, sir.
108 some questions are there but only probability questions we can solve and other questions we cannot solve so either we have to choose only probability sections and keep on doing that is one of the best strategy
यस
so which one we will do madam
यस सर
we'll complete only probability questions right
यस सर
that is only one possibility and any other questions which are easier right and in the meantime you will be doing the complete the assignments right that is better
यस
so today I think we will stop over here okay
ओके सर
because we are not able to do much today because